This video is brought to you by Squarespace. In the mid-1950s, the US Navy needed a new aircraft. But not just any new fancy jet plane, rather this one had a special mission that had a specific requirement. It would have to take off vertically. The Navy needed an aircraft with the capability to fight against enemy aircraft, but without requiring an aircraft carrier. The idea that merchant ships or other small craft could have their own fighter escorts. So the Navy would initiate the Vertical Takeoff Jet Day Fighter Program, or TS-140 for short. The specific requirements was, first obviously it would need to take off vertically without a runway, but it would also need to be simple to build and maintain, jet powered, have 4 Sidewinder missiles installed or rockets, and be able to land in all conditions onto a deck of an aircraft, such as during a storm. Lockheed was the first out of the gate with the CL-349 tail sitter, which would take off vertically, rotate its tail fin forward to get clearance, and then land traditionally with a landing gear. Then there was the Ryan Model 112 VTO high altitude visual fighter proposal, which would take off from a suspended hook and wouldn't actually touch the ground. And then there was also the Bell D-188, which we've covered here on the channel already, which had 8 jet engines and would also be later proposed to the US Air Force as well. But our hero of the story today is even more insane, and approached the design requirements with some pretty outlandish ideas. It's crazy to think that the Canadians invented the X-Wing fighter a good 20 years before Star Wars. And if they had better marketing, it could have been an active fighter for the US Navy. But it seems, despite the excellent pamphlet and work they did on the drawings, without a website, they didn't really stand a chance. They needed Squarespace. That's right, the amazing Squarespace website creator has arrived with a brand new amazing feature, a cutting-edge AI, to unlock your strongest creative potential. Squarespace will actually recommend a fantastic design to reach your online goals and create a beautiful, more personalized website, crafting a bespoke digital identity. You'll never look like a template again. But building a website is only the beginning, because with Squarespace you can now run email campaigns, you can get more customers, and you can even launch courses. That's right, if you want to teach something on the internet, which seems like everybody's doing these days, Squarespace is now your one-stop shop for your entire educational portal. And of course, I use Squarespace myself with my own online store at foundandexplained.shop. So if you want your own website, head to squarespace.com for a free trial, and when you're ready to launch, go to www.squarespace.com/found to save 10% off your first purchase of a website or a domain. And I have to stress, for the Canadian team at Avro, this wasn't just about contracts. This was a shot at proving that Canada could lead the aerospace world. The engineers weren't just trying to meet the Navy specs, they were trying to overshoot them and build a legacy. Called simply the Avro TS-140 proposal, it would fix all the problems with the previous tail sitter designs, and it would be as simple as possible. And to do that, it wouldn't be a tail sitter at all, rather a flat riser. It would feature 2 pairs of unswept wings with 4 Orpheus jet engines mounted on each wing tip. The aircraft's X-wing configuration is apparent when viewed from the head-on angle, prefiguring the famous Star Wars design by several decades. The idea behind having 4 engines was that 4 separate nacelles was lighter than a single engine in the middle, but provided the same amount of thrust. Plus, the lack of ducting around the fuselage to transfer the vertical thrust would not only save on weight, but it would also save on space. The podded engines left the fuselage free for installations of the cockpit, fuel, armament, and equipment. Either rockets or 4 Sidewinder guided missiles could be carried in the belly of the aircraft to make it the perfect bomber interceptor. No guns, because back then the future of air combat had moved beyond dogfighting, or so they thought. The undercarriage had no wheels, instead pads were attached to the ends of conventional extending legs with a simple operating mechanism. although future revisions would actually add wheels to the end of these legs later on. They even left room in the nose for advanced radar and electronic gear, including the AN/APS-67 and a whole bay of modular avionics, ready for whatever the 1960s threw at it. It was future-proofed in theory, even though the future never showed up. The whole aircraft itself wouldn't have any folding wings and fit within a 50-foot square platform. As it was designed to be as light as possible, the low aspect ratio wings didn't need to be very large, with the forward wings lower to allow the pilot to have maximum visibility. And about that pilot. Because it was a flat riser, the pilot could sit traditionally and not have to lean back for takeoff, and could even access the cockpit with minimal effort on the ground. You could control pitch and roll like a normal fighter jet, but the engines themselves would auto-correct for any wobbles. Rudder pedals didn't twist flaps, they actually changed the direction of the engine thrust. It was like giving a pilot invisible hands on each corner of the jet. Additionally, because I know a lot of aircraft engineers and mechanics watch this channel, ease of access to the engine nacelles as well as the actual fuselage meant easy maintenance. Swapping out weapons and components was simple, and entire engine nacelles could also be taken off in a beat. It was simple, it was light, and it was deadly. But I bet you're wondering, how exactly did it fly straight up? Because it's not what you think. In combat operations, Navy fighter aircraft need to get from below deck and into the sky as quickly as possible. And the TS-140 was designed to do just that. You might be thinking that for vertical takeoff, those jet engines would rotate on the wings, like the other designs that we have seen from this era, like the Bell D-188, but actually no. It would involve a system called an all-render devised flapper valve cascade, which is one of the cool names I've come across, but also called an eyelid. Each of the bedpost range Orpheus engines had a diverter valve in its jet pipe feeding to a patented Avro Canada eyelid nozzle for VTOL. That eyelid nozzle was controllable for fine pitch control. With the turbojet's diverter valve closed, forward thrust was provided in a more conventional way. The system was so clever that it didn't need to rotate the engines at all, just redirect the jet thrust with a simple flapper valve and some shockingly effective nozzles. Avro was solving in 1956 what most countries wouldn't attempt until the Harrier jet. A typical mission would start with the carrier craft, potentially a custom one built for this aircraft, pulling one of the 28 aircraft onto the deck. There would be a custom tender vehicle that would be incredibly low and have a driver off to the side. It would be able to move under the aircraft and reload the fuel and missiles in the central fuselage. It could even provide air conditioning to keep the pilots cool in tropical environments. Not bad, Avro. And as if the tender vehicle wasn't already wild enough, it could fly. Not on its own, of course, but the TS-140 was designed to carry it underneath like a delivery drone. If a forward base needed support, one of these jets could sling its own tender into the combat zone, land, and set up shop without waiting for a supply ship. It was like a fighter jet that shows up with its own mechanic riding shotgun. Utterly bonkers, but Avro generally thought it through. For takeoff on, say, a traditional aircraft, the TS-140 could operate off to the side and away from traditional aircraft catapult operations, meaning it would work in tandem with AWACS or other aircraft operating. If the vessel didn't have a deck designed to accommodate the downward thrust, a special fixture on the side of the ship could be installed. This would be essentially a grate that would allow the thrust to flow underneath and could be hinged away when it wasn't on use on the ship. Once the takeoff area was vacated, the next wave, air quotes, of the TS-40s could move up into position and take off in under 2 minutes, with up to 18 VTOL aircraft in the sky in under 10. For landing, the TS-140 could pretty much land anywhere on the deck, although ideally away from the taking off aircraft. In emergencies, because it was a flat riser, it could also ditch into a calm sea, damaging only the forward engine nacelles that could quickly be replaced, something that a tail sitter couldn't quite nail. And Avro wasn't just dreaming with all these designs, they were building. The company had laid out a full 1-year test program to validate this design. They planned to use the older Orpheus 3 engines to prototype the jet deflection system while waiting for the newer, more powerful Orpheus 11s to arrive. Full-scale engine pods, thrust vectoring nozzles, control algorithms were all now in motion. This wasn't some napkin sketch, it was a real development effort with rigs, pilots, and actual smoke-bleaching jet parts. Because this was Canada's shot at the big time, and they came in swinging. Everything was riding on this, years of work, national pride, and a chance to rewrite aviation history, all leading towards one fateful meeting with the Navy. While they waited to hear back, Avro actually built a scale test rig to prove the jet deflection system worked. Using 1/7 scale nozzles, they managed to curve the jet blast 90 degrees and still get over 95% of the expected thrust. No rotating engines, no afterburners, just clever airflow control. They even tested different nozzle lengths, flap shapes, and even turning valves to fine-tune the design. And honestly, this was one of the most successful parts of the whole project. But what exactly did the Navy think? Well, on paper, Avro claimed that this thing could push past Mach 2, but in reality, it was more like Mach 1.75 with a prayer, and even then, that was with optimistic thrust numbers. The Orpheus engines just didn't have the muscle. They burned too much fuel, and the airframe created way too much drag. Even without afterburners, the TS-140 was basically stuck pretending to be a supersonic jet. The Navy wanted a Mach 2 killer, but what they got was a flying brick with dreams. Even Avro admitted it couldn't accelerate fast enough to meet the specifications, and they had to downgrade the mission to Mach 1.75 just to keep a straight face. The Navy was also a little bit worried about the aircraft's complexity. Whilst other TS-140 submissions were even more complex, such as Bell's D-188 for example, which had 8 engines, with 4 of them on tilting wingtip pods, in the end the US Navy decided to abandon the entire TS-140 program. So even though the Avro TS-140 had beaten the D-188, it's likely that the Avro VTOL fighter would have suffered a similar fate because of how complex it was. And for Canada, this was devastating. All that effort dismissed with a shrug. The Navy walked away from the entire program, and Avro's last great hope never even left the drawing board. In the aftermath of its TS-140 submission being rejected, the VTOL section of Avro Canada's Advanced Projects Group considered alternative designs. In review, the TS-140 submission was seen to have 3 key disadvantages. A wheel-less undercarriage, which required a separate mover and loader to move it around, and that's why they would add on wheels later. The complexity and the expense of 4 main engines, one engine would be cheaper, and the need to license another firm's engine design. They didn't have their own engine technology. It was flaws all the way down. But there is also another theory, and I want you to put on your tinfoil, one that still sparks debate today. Some believe that the TS-140 never stood a chance, and it wasn't about performance or cost, it was all about politics. That the US didn't want Canada becoming a serious aerospace competitor. Was the TS-140 quietly killed to keep Canada in its place? It's speculation, sure, but when you look how advanced this design was for 1956, you have to wonder, was the military-industrial complex of the US worried? And speaking on its design, I actually do want to touch on that in a moment. Now, this comes with the ability to look back in hindsight. We now know a lot more about supersonic jet design and about how jets fly in the sky, that we can kind of poke some holes in this crazy X-Wing configuration. There are a lot of design choices that are very obviously from 1956, and it shows in a big way. There's straight wings, there's no aerial rule, there's 5 shock cone forming leading edges that would not only lead to tons of drag, but hideous turbulences as well as maximum wave drag. This would be a vomit comet and seriously make anyone sick. And because of this design, I don't think this had a hope of breaking Mach 0.8 unless you put rocket engines on it, which, looking at the engines that were selected, was definitely lacking power. And not to mention the sheer amount of fuel it would burn, they really didn't have a huge understanding of the fuel situation back then of just how hungry VTOL planes can be. But if I was a pilot, it wouldn't just be the vomiting I'd be worried about. I would also think this would be deadly. Let's ignore how you would land this thing without seeing underneath, and that's something that's always been an issue with many VTOL aircraft and helicopters. The real aerodynamic gremlin here was the rear wing. It was practically guaranteed a stall in high G turns. Combined with unswept wings, no area ruling, and a drag profile that made even the Starfighter look aerodynamic, this thing would have flown like a wet fridge in a headwind. Forget Mach 2, even Mach 0.8 would have been a fight. It would make a better pilot murdering machine than the Starfighter. But don't feel sad, because Avro Canada was cooking. A year later in 1957, they would bring to the world a fantastically advanced aircraft that was so brilliant that it would easily enter production and change the world of aviation as we know. And this would fly straight as an arrow. This video would have not been possible without help from Retro Mechanics, who provided the original and insanely detailed source document. I recommend you go check out their Patreon link below and all the other aircraft that they have. They have some absolutely brilliant planes on there, and I can't wait to see what you guys think. Thanks so much for watching.